I've written down the first line. It's the easy line, right? The part that follows is a bit trickier. It's the thing that makes completing the square. But I sort of left you a little bit on your own. This was easy because we already knew what we were expecting. The question is, what do I add to both sides here that will give me, like I have here, a perfect square on the left? Okay, what number do I add? Okay, and to help you recognize what number you add, I'm going to call you back over to this example because we did it before, right? Being that there's an x plus 3 here, right? This 3, it leans toward this number and this number, right? Do you see that? How does the 3 turn into the 6? You double it, right? You double it. That's how 3 becomes 6. How does the 3 turn into the 9? The answer is you square it, right? If I gave you another example, for instance, this guy, x plus 5 all squared, and I asked you to expand that, expanding is generally easier than factorizing, it's going to give you this, 10x plus 25. You see again, that 5, the 5, it turns into the 10 by doubling, and it turns into the 25 by squaring, right? Okay, now what are we trying to do? We're trying to go not from this number to each of those numbers. We're trying to go from this one, we've got that one, there he is, minus 12. We're trying to go from him to here, right? So, remember how you told me to go from 3 to 6, you double? So how do you go from 6 to 3? The opposite of doubling is halving, right? You halve it, you divide by 2, okay? So to go from 6 to 3, you halve it, and then you go from 3 to 9, you square it. Let me test that again. To go from 10 to 5, I halve it, and then to go from 5 to 25, I square it. That's the two things I do that complete the square. I halve, then I square. In fact, that's so important, I'm going to write it. I halve, then I square. Okay, halve, then square. That's a bit funny to wrap your head around, but watch how it works. Minus 12. Would you halve it for me? 6. Oh. Negative 6. But when I square it, it won't matter, right? 6, then I square it, that gives me 36. So I'm going to add 36 to both sides. Now I have a square, right? This guy over here, I can factorize, right? I'm going to use that same step that you told me to work out the factorization. You're always going to get that x out the front, right? But when you halved it, that's when you got this intermediate number, right? Which you squared to get the 36, right? You see that? So halving and then squaring, that's what gives you this number. But halving just gives you that one. I'm done. Okay? What do I get on the right-hand side? 16, which conveniently is a square number because these you've already worked out. There were no weird irrational surds or anything like that. What do I do from here? I'm at this point right now. I take the square root. Okay? So I've got x minus 6. The square root of 16 is 4, but I don't just have plus 4. I have minus 4 as well. Okay? And the last thing to get the x by itself is I add 6 to both sides. Okay? Now here are the two solutions, but I could do some simplifying here, right? One of them is minus 4, and the other one is plus 4, okay? But you already knew this, didn't you? We solved this, oops, sorry. We solved this just before, and we got these same solutions, okay? So this method is always going to work, right? We didn't need it for this question, but you do need it for some, right? Okay, last one. Again, we're going to take a question we've already done so we know what the answers are. But because it's not monic, you have to add one extra step in, which makes things look a little messier, but it'll be fine, okay? So, being that it's not monic, I need to make it monic. All of these questions with completing the square, they need it to have just a single x squared out the front. So, being that I've got 8 of them, what I'm going to do is I'm going to divide every single term by 8, okay? I'm going to divide this one by 8, and this one, and this one, and this one. Okay, you've got to divide everything. Right? 8x squared divided by 8 is just x squared. Minus 2x over 8. I can do some cancelling there just a little bit. That's minus a quarter x. You okay with that? I can't really do anything to that minus 3 over 8, can I? He just kind of potters around there. And 0 over 8 is still 0. Okay? So this looks a little worse because it's got fractions, but that's okay. We can still handle these, right? I want to get a square over here. That minus 3 over 8 is in the way, so I'm going to kick it over the other side. X squared minus a quarter x, and that'll leave me with 3/8 on the right-hand side. And now here comes my completing step, right? How did I add this number? What did I do again? I halve, then I square it. I halve it, and then I square it. So half of this, half of a quarter, here's a quarter, right? There's a quarter over there. So half of that is this guy. That's an eighth, right? It's even smaller. So I'm going to add an eighth squared, right? An eighth squared. Now, for reasons that'll become clear in a second, I'm just going to write that without working out what it is, okay? I'll work out what it is in a second. I've added it to the left, so I better add it to the right. Is that okay? After, then I square it, okay? Now, the reason why I was so lazy over here in just writing an 8 squared and not writing 1 over 64, which is what it is that over here, I'm just going to use that eighth, right? This is going to be x minus an eighth, that number, okay? You can see if I went back here, right, you would double 1 over 8, which would give you a quarter, and then you would square it, and it would give you that an eighth squared, okay? All right, now on the right-hand side, I'll deal with this guy. This is 1 over 64, right? 1 over 64. I've got fractions here. I know you can do this on your calculator, but the more you use your brain to take advantage of the fact that you can do things like this, the stronger it gets, okay? So if 3 over 8, if I want to add that to something over 64, how am I going to make this common denominator? I'm going to have to multiply by 8, right? To make the denominator 64, which makes the numerator 3 times 8, which is 24. Okay? They're both over 64. What's 24 plus 1? 25. Okay. I'm almost there. I'm so very close. And we'll finish this and then you can head off, right? What step am I up to? I've got a square on the left-hand side. How do I get rid of it? Take the square root, right? So I get that. The square's gone. I get a plus or minus on the right-hand side. 25 is a squared number. What's the square root? 5. And 64 is a square number. I know that because I got it by squaring. It gives me 8, right? So now I put that 1/8 over the other side. And there are my two solutions. Let me just make it clear. Here's the minus 1, and here's the plus 1. An 8 minus 5/8. That's minus how many 8s? 1 minus 5, that's 4. Minus 4/8 is minus a half. Does that look familiar? Or 1, sorry, that's an 8. 1 plus 5, that's 6/8. 6/8, you can simplify that. That's 3/4. Does that look familiar? Nailed it.